Good morning, everyone. Welcome to the payments track here at Authenticate. We are going to hear from Doug about secure payment confirmation. So all the questions you had in the previous session around SPC, Doug will be here to illuminate us. And with that, over to you, Doug.
Thanks, Christian. Hello, everyone. My name is Doug Fisher. I work with Visa, work with Henna in the authentication and identity team. And I've been working on secure payment confirmation through the W3C, EMVCo, and FIDO for, I guess, the last 3 years. I do a lot of work with standards bodies. I've spent maybe 10 years working on the EMVCo side, developing the 3DS payment authentication standards over the years, and have been working in payment authentication for a very long time. I wanted to start just with a personal note. So I was coming to the conference, and I told my kids that I was coming to Authenticate to speak. And so naturally, the first thing that they did was Google Authenticate and my name. And they pulled up a YouTube video of me talking about secure payment confirmation 2 years ago at the Authenticate conference. And they had a great time sharing the video and saying, is this what you do? And can you make a living at this? And had a very good time with it. But because I know they're going to also view this video, I just thought I'd do a shout out to Alice, Clark, Nicole, and Joseph. Hello. So now that the personal side is done, and now that the legal side is done, we'll go into the context of what we're trying to do with secure payment confirmation. So we know e-commerce is growing, but e-commerce fraud is growing at a faster rate. And obviously, we're all focused on addressing payment authentication as a key issue to resolve for the future. Consumers expect fast and easy payments, but we do need to authenticate these payment transactions. And authentication typically adds friction, and that results in abandonment of a shopping cart and a decrease in performance of payment transactions initiated through the e-commerce channel. So we're really looking at FIDO and passkeys as a way to address these challenges, and secure payment confirmation was designed to do just that. And I'll eventually get to the slide that tells you what it is. But this is a throwback to what Henna was talking about, where you have a situation where, let's say, in this use case, the merchant is a relying party, and they are authenticating their customers through FIDO to their website, but they want to share data about that FIDO transaction with the issuer. And so Henna explained how we could use the 3DS channel to share messages. The important thing to note is that when, let's say, a merchant uses FIDO through WebAuthn to authenticate a credential that they created on their website, that is considered a first-party transaction. So I just want to plant that, make sure everyone's aware of that. And that's the use case that WebAuthn supports. So what we really want to do is address the use case where the payment authentication is happening in the third-party context, where actually WebAuthn does not support this flow. So a typical use case is a merchant needs to get authentication for a payment transaction, but requires that authentication from, let's say, an issuer, from a relying party. But they would prefer not to have the consumer leave the context of the merchant domain. They'd also prefer, just like they could do in the previous use case, of retaining control of the user experience because of the abandonment issues that typically occur when you have challenges that are being provided or performed by an issuer through an iframe on the merchant site. So they want the consumer to stay on their website. They still need to accomplish authentication with the issuer who has created credentials, FIDO credentials, for their cardholders. And so what the merchant really wants is the ability to invoke FIDO, a ceremony, from the merchant domain using an issuer credential for that cardholder. And that's considered third-party authentication. WebAuthn does not support that, but that's actually the goal, if you will, of secure payment confirmation, which is to solve for this use case, among others. So SBC is built on FIDO and WebAuthn. It's another layer. It's a draft specification being developed by the W3C. It's designed to do a number of things. One is dynamic linking. And dynamic linking involves the cardholder giving consent to a financial transaction, in this case a purchase where you might have a purchase amount, merchant name, and date. The consumer sees that transaction details in a secure user interface that's provided by a participating SPC browser that is signed as part of an assertion provided to the relying party to validate. So the relying party gets cryptographic proof that the consumer saw the details of the transaction, gave their consent, and it was signed using a passkey that was previously created for that cardholder. The way authentication is accomplished is through biometrics, or whatever method that the consumer uses to unlock the device that they happen to be using for this transaction. So it's something that they're familiar with. It's easy, it's fast. And the ability to support cross-origin credential sharing is a true considered superpower of SPC. So what that means is that if you're a relying party, let's say an issuer, your SPC credential could be invoked on any merchant site in a third-party context using WebAuthn and FIDO. So that is quite an accomplishment. And in the case where you're using SPC with 3DS, and let's say the consumer cancels on the SPC or the WebAuthn prompt, it will gracefully degrade to a standard 3DS authentication. So if you look at two different implementations, the first one on the top row here is with secure payment confirmation. And the bottom one is using standard WebAuthn. Both start at a merchant checkout experience. The difference, the reason that SPC has only 4 screens and the other one has 7, is that you need to redirect from the merchant domain over to the relying party to accomplish authentication. And then you have to redirect back to the merchant. Whereas with SPC, there's no need for a redirection. And so in terms of the benefits, merchants really like that the consumer stays on their domain. And they also like that they don't have to create an iframe, which is required for a 3DS challenge in the EMV code specifications. The consumer likes using FIDO and biometric authentication to authenticate. And as far as issuers, they like that they can validate credentials that they've created without having to go to the trouble of supporting all different operating systems and browser versions and providing very user-friendly interface as part of the challenge. They provide data to SPC, but it's the actual UI is rendered consistently by the supporting browser and the issuers don't have to worry about the formatting of that on that particular device. So what I am going to try to do is I have like a race here. So it's between SBC on the left and traditional 3DS OTP authentication on the right. So I'm on a merchant site, and I'm going to click buy at the same time. So I filmed this on my phone using an implementation. So on the left, we're doing payment authentication. We get the SBC screen. We do our biometric. We do the 3DS verification, and we're done on the left side. On the right side, I'm picking up my one-time password that has been sent to my phone. I'm going back to the merchant domain. I'm typing in my OTP, and then I'm going to authenticate and whatnot. So it is definitely very much faster to do authentication through the 3DS side, so through the SBC side. So that clearly is a very nice user experience. So what have we been doing? Visa, obviously we're very excited about SBC. We've been piloting SBC about, I guess it was over a year ago, we did a pilot of SBC, but in a testing environment. So we implemented SBC, we had integrated to 3DS, and we're taking consumers through usability testing, through focus groups, and developing feedback on the UI and what consumers understood about SBC authentication. And that went pretty well. We provided feedback to the W3C and EMVCo and FIDO. And because the pilots went well, we took them forward into production. So we have 2 production pilots running in Europe, and I'll explain a little bit about them. They are covering this 3DS payment use case, and there's other ways SBC can be used, not just with 3DS, not just with, well, actually payments are probably pretty critical to SBC. And the objective of the pilots is to identify any problems that we could come up with that might prevent SBC from scaling globally. So from the technical or consumer perspective, is there anything that's going to hold up SBC from scaling? So we did 2 independent pilots. The first one was with PlusCard. They are a PSP in Germany. PSP? They're a payment service provider in Germany. Sparkasi is the issuer, and DKB is an issuer in Germany who are participating on the pilot. Oh, I'm sorry, they're an issuer processor, PlusCard. Is that what you were saying, Mike? Yes.
I was actually asking for the acronym to be spelled out.
Oh, okay. And then on the merchant processing side, we have Amos IT, Merchant Tesario. The vendor NetCetter has implemented SBC with 2311, the latest version of the 3DS specifications, and they also are providing the FIDO server. And then the second pilot, Spanky, issuer in Finland, is participating in the pilot. Intersect is providing 2.2 implementation of 3DS. And in order for the current 2.2 version of 3DS to work with SBC, which has been specified in the 2311 specification, we needed to create an extension, right now proprietary, but this is just because it's in pilot testing, so that 2.2 we could test whether we could get SBC to work with 2.2, and actually we can. So that, I guess the overall good news is that we've implemented this in production. It works, SBC works, and also we're able to confirm that the 3DS specifications of how SBC and 3DS integrate together, that also works. So that's the good news. I'll give you some high-level results of those pilots in a second. So I do want to show you just two examples of credential creation and using a passkey that's been created with SBC. Now, I didn't want to use the actual production UI because it was either in German or in Finnish. And so this is just an example merchant in English to make it a little easier. Actually, as part of the pilots, we learned a lot about how to try to communicate the value add of passkeys in German and Finnish and what terms make sense in those markets. And that's a whole nother thing to talk about. But anyway, let me see if I could start this video. What you're going to see here is at a merchant site, the merchant is trying to take a cardholder through a payment authentication process using a 3DS. So in this pilot, what we've done is we've taken the consumer through a 3DS authentication, and if the consumer has been authenticated successfully, the issuer, who is the relying party, is going to prompt the consumer to create a passkey, a SBC credential, to use for subsequent authentications. Okay, so you're going to see going through a 3DS authentication process that is going to use the out-of-band technique, which is they're conducting the transaction on a laptop, they're using their phone and an out-of-band banking app to do the authentication. And then you're going to see a prompt where they're asked to create a credential, or if they want to create a credential or not. So let me see if that works. So we're adding an item to the shopping cart. We're putting in our payment details. 3DS is being invoked. We're using an out-of-band app to authenticate the consumer. And after successful authentication, what's going to happen is the issuer is going to display this screen. I'll just pause here for a second. And what it says is create a passkey on this device. It tries to explain a little bit about what a passkey is, the card PAN that the passkey is being created for. And in this pilot, what we opted to test is allowing the consumer to customize their device name. So we allow them to enter in a nickname so that later on, when, let's say, the relying party wants to provide a site to manage passkeys, that they'd be able to more easily recognize the passkey that they've created. So we were a little concerned about this because we don't want people to spend 5 minutes thinking of some creative name for their device or anything. But it turned out that it wasn't a problem, and folks got through the credential creation process pretty quickly. So anyway, let me continue. Oops. When I started the video, it started from the beginning instead of from where I had stopped it. So I'll let it run. So again, we're going through the ID and V. We're creating a passkey. We're creating the passkey. Then through WebAuthn, we're going to use our biometric to authenticate. The biometric was successful, the passkey was created, 3DS completes, and the payment was successful. So that is, in the pilot, the way that we were enrolling consumers. Then as far as authentication, it's as you would expect. We would go to the shopping cart, we'd check out, enter our payment credentials. Behind the scenes, the relying party knows that there's credentials for this consumer. SBC is invoked. You could see the transaction details. They hit verify. WebAuthn comes up. They share their maybe biometric, and then the payment is completed. All right, so that's pretty straightforward and not a bad consumer experience. So as far as the usability study side of this, we really were trying to understand with this kind of complex model where you have now a browser participating, you have authentication happening on a merchant domain, you have a relying party there. How is this to consumers? Do they understand the roles that each party is providing? Do they know who's authenticating them? Do they know what that pass key is going to be used for? And do they know when they go to another merchant site what to expect? With SBC, the pass key is created by that participating browser, but not all browsers are participating. So right now, all we have, and fortunately, we have the support of Chrome and Edge. But if a consumer uses Safari, for example, SBC is not supported currently. And so, do consumers know what to expect and how they can get utility through SBC when it's not supported across all platforms and browsers? So we're doing a lot of testing about feedback. As far as a summary of what we heard, I'll just read off this quote from Espanki, one of the pilot issuers who felt that SBC will definitely add value to the whole payment ecosystem as it removes friction of the authentication process and reduces abandonment. I truly believe that SBC will improve the competitiveness of card-based payments in emerging payment market. And from PlusCard, there was a quote, "I like to enroll for SBC whenever I have the option to, as the authentication process is faster and easier than any other method." I should mention that the pilots that we have done have so far been friends and family and with consumer focus groups and employees of the issuers who are participating. The pilots have not yet gone to full rollout, consumer rollout. There are some enhancements coming to SBC, and there were some announcements that Google made at the TPOC conference like 2 weeks ago or a few weeks ago. And so that's exciting and something that we want to test again with our pilot partners. As far as next steps go, we definitely want to encourage all the platforms and browser vendors to support SBC. There is this sense that SBC cannot scale unless we have widespread adoption of the standard in order to provide the value proposition to consumers that they'd expect from a global payment authentication method. So we're definitely encouraging the specification to be embraced, refined, and then adopted by everyone. Further testing and development of SBC obviously is needed. I mentioned, at the TPOC conference, Google mentioned a few updates to the SBC UI. I showed you the happy path. I didn't show you the unhappy path through SBC. If, for example, the relying party thinks there's a credential on the device and invokes SBC, and there's no credential there, you get this error screen. And it says something like, additional authentication will be required. But from a relying party perspective, you don't know if there was a timeout, whether the credential wasn't there, whether the consumer hit cancel on the SBC screen. So you get no information to know what to do with that error. Anyway, so there are some enhancements coming out that are being thought of to address these unhappy path use cases, which is great. And I really think SBC shows the power when standard bodies come together and collaborate on solutions to address the needs of the industry. And we're really excited to continue that collaboration. And I think we're really optimistic that SBC, can realize the potential that it potentially has within financial services. Okay, that's it. Thank you.
Thank you, Doug. We are pretty much out of time, and we have a whole list of questions here in the app. I'm going to ask one, and then I think we'll have to call it. But the one question I had here, maybe SPC with passkeys is not PSD2 compliant as the key is not device bound. How is Visa able to use SPC and be PSD2 compliant?
So PSD2 compliance and the interpretation of PSD2 compliance is something that our legal department and our European liaison department are dealing with on a daily basis. But we do, one of the enhancements that are being worked on, and you might have, some might have seen it, is that there's a proposal to have device binding with SPC. And it's called the SPC device binding proposal. And so when you conduct SPC, the browser itself will potentially create a device-bound key that will be used to help relying parties identify whether they've seen this device before. So that's exciting. And I think when, in a world of syncable passkeys, when we get these types of device-bound signals, it will make it a lot easier to meet financial regulations globally.
Sounds great. Let's thank Doug again.
Okay, thanks.